predictive analytics is a cornerstone for the modern business intelligence. It has several essential use cases in sales as well. So here, let's look at the role predictive analysis plays in sales analytics. Aldis, very nice to see you this morning, and I'm sending you live. Hi, Aldis.
Hi, thank you. So I'm sharing my screen.
Yes, we can hear and see you nicely.
Very good, very good.
And
yeah,
okay,
well. Last week we talked a lot about predictive analytics because it's a very hot topic. Of course, when we think that that is really what we want to predict some future, because that is something we don't have today, and we think that we will see something special and we could use it. But in real life, I could say that from the practice point of view, the predictive analytics is more to the ground. So we need to understand some basic things of what predictive analytics can do for us. And usually, I could say that the most common mistake of predictive analytics is starting to think from data. So you start thinking that what kind of data you have. Like I have 10 terabytes of data, 5 terabytes of data, and for sure we need to get something out of this data. And that's something that we are struggling, like the total business intelligence community, because we have more and more data, and we think that data is like new oil and it's driving the insights. It's of course helping us to get there, but if we need to look from the predictive analytics itself, I could say that we need to use the framework I borrowed from the business intelligence gurus. And like first question you need to answer when whatever you think about predictive, and let's do predictive analytics, let's do smart insights, call them what you want, as you want. But first question you need to answer: if it could be predicted, what it will be. And ask yourself, let's directly, you don't need to answer me, answer yourself, to yourself. In sales organization, imagine you are running sales organization or some different organization in your enterprise, and you say, oh, we need actionable insight, and we need actionable insights, we need some. And if I ask you what it would be what it would be to predict for you, so it could, if you can predict it, what it could be. And it's a very hard question. It's actually it's very hard to answer. And if you can answer, you could do probably it without data. But let's see what's next. If you say, okay, if I could predict in sales and B2C, for example, sales, if I could predict what customers will buy, for example, what I can predict it. And I could predict it quite, for example, cheaply enough. So I could predict what they will buy. And next, what will be an impact? What could be expected results of that? So I expect that if I could predict what they buy, I will offer them, and they will buy it instead of they are usually buying. And third, what could be impact on organizations or on strategy? So if they will buy more, that I will sell them. So I can sell them what I want. What I want, maybe more than they are ready to buy. So what impact on the strategy it will be? It will be like we will have a more balanced portfolio, product portfolio. We will have a better cash flow, and usually the better cash flow. Even today, I think the most important thing of what analytics could give us is to get a better cash flow. And just the last thing is what kind of data we need to accomplish that information. And you see that we are not starting in predictive analytics. We are not starting with the data we have, but with a goal, with prediction goal we want. And for example, for this bootcamp and for this contest, for those who are creating reports, so it's important not to get data, but to imagine what you could predict. If you can answer if you have many ideas on the first, you need to go into predictive analytics market, and you will be the super consultant for that. But let's look closer. And sometimes we think that BI and advanced analytics, or machine learning, how we call it, or it's a new name actually for data mining. So we imagine that these are two different things, like machine learning and BI. But actually, I could say that from all my experience, machine learning should serve and must serve BI, business intelligence. Because as we discussed it last week, the business intelligence actually is nothing more than the way how we explain how the organization works. So business intelligence is not a bunch of numbers and charts. It's a way how we explain machine learning, how we explain the organization, how organization works, how business model works, how we earn money and do interpretation of our business. And then if you look at this schema, this is the way how we could show that how machine learning serve for BI, for data-driven decisions. And when you see that on the bottom, like number one, we're using uncommon data sources, like it could be structured, semi-structured, unstructured, and sometimes it's operational data, emails, communication, documents. A lot of data currently we have in documents. They are in files. They are not in structured databases. Sensor data for something. Imagine that in a couple of years, even experts say that after COVID-19, for example, insurance, there will be a lot of changes. We will not pay for car insurance for yearly payment or quarterly payment. It will be pay-per-use, most probably, and we will need some sensor data, how many kilometers we are driving on with our car. So because of that will be calculated the price for our car insurance. There could be video files, images, scans, and many more. And the second step, on top of that, we could use machine learning, different techniques. I will show you the nice compilation of all techniques to think about. I was using this machine learning techniques, and on third point, we get actually some new data, because machine learning is creating a new data usually. For example, when you do a forecasting or classification, you get a new data because you using your existing data. You add a column with class, or you add other columns with forecast values. So you actually create new data of your data. So that is the idea of this machine learning and predictive analytics, to create data you never had, and now you can get it. And then you, on the number three, on the three level, you get a product forecast, communication metrics, user activity, and so on. And number four, you put this data in your existing reports or create new reports, and that is how you get this actionable insights. And even more in the era of automation, they are currently on living in when we are talking about proactive analytics. And I like that story that Microsoft is building about this idea of proactive analytics, that if we do, it's not just that we are putting this new data into reports and try to see something new, that we entirely could use it for automation. It means that the new data we get could trigger actions in application in CRM, like creating new tasks in CRM for the new product or client data, or if we create a product data that should be offered to particular client, maybe not just show in the report that you see we recommend to sell this product for this client, but we just put it as a task in our CRM system. So that is a main understanding of predictive analytics role in BI, that it is serving the way how we consume data. And if we talk about what kind of machine learning techniques we could use, there is a list of them. You see that for the particular use cases, if we want to do customer segmentation or product categorization, yeah, we could use a clustering functionality, clustering machine learning technique, or classification, or different other kind of techniques. But again, remember, you could start to think about them only if you answer this first question: what you want to predict? What is this prediction? And prediction, the idea of prediction, as you heard previously, so as I mentioned, it's not related with the data, not related to machine learning, any technique. You don't need to answer this question about what to predict. It's a business question. It's not a technical question at all. And if we look at what we can do even more with machine learning, if we think that it's just classification or some classical data manipulation things, that today it's even more. There is, for example, Microsoft Cognitive Services for extracting. If you have an images from your security camera, it could recognize people. It could extract gender and age, for example, from your retail store cameras. Which is actually not allowed in Europe because of GDPR, but technically feasible. You could, for example, with language cognitive service, you could get out the sentiment analysis. Like you have a list of comments or comments or feedbacks from your client, and you could automatically detect is it positive or negative, so and build it in report. I know that for cognitive services, Igor Smacinch will make a presentation this week, so and show in details how you could use it in your Power BI report. So attend this session to get more. But the services, pre-trained AI services, are there, so you could get a lot of things out of it directly in Power BI. And for example, even more what we get in Power BI right now, it's AI in science. And you see in Power Query View, there is a text analytics, vision, and Azure machine learning services available. Okay, it's currently maybe available more for premium subscribers. So you could really, currently we are not mainly capable to get these functions, but we could get it in other way. But it shows that we will get this analytics soon, also in regular Power BI versions. And to understand machine learning modeling, so we talked that we could build the models and then do all this nice stuff. What it means actually, that means that we are using some data, we are cleaning it, we're training model, using some algorithm, score it, and evaluate it. So that is how the machine learning model look like. And actually there is tools like Azure Machine Learning Studio, where you could get it and do it for free. And you could build your machine learning model without a lot of programming. Actually, it's a low-code platform where you could build your machine learning models easily and then deploy and use for your BI reporting. Like here is a this most popular demo model of the Titanic survival. When you see that we have a CSV file with data, we clean missing data because it's very important to clean data, use a clean data for machine learning, and it's natural, because if you train machine with some poor data, it will be poorly trained, and you will get a bad model. And we split data, and then for training we use a two-class decision jungle, and then we evaluate models. So that is how we do that. And important to understand that the quality data is essential for machine learning. That is why not always we could use this technique, because we really need a very good data. And imagine we have the stock market, stock price, transactions, and usually in machine learning, we want to predict one column. Like here, we want to predict the stock price, or we could predict some other price like market share. But usually when we get the data like this, you see that there is a different columns with some missing values. So before we go on, we need to clean this data, like the birth rate. We need to get a nice right form or height, convert into one figure, clean missing data, provide classified data. So that is how we can clean data and prepare it for machine learning task. And currently, we could use Azure machine learning model with R or Python script directly in Power BI, Power Query. And you can see that there is a very simple script. We will not go through this. I'm just showing it. That I will show you Excel example, but it shows you how it's easily could be used. And now let's go to demo. So idea that how we do that. We will use Azure Machine Learning Studio. You see that you could find it, and there is a free subscription possible for it, or for a larger amount if you need. There is a $10 per month subscription. So this is quite affordable. So I'm logging in just to show you how it works. Yeah, and in this Azure Machine Learning Studio, you could build your models. For example, if you want to, in your report, as we've seen in this proactive analytics, that you convert data in with some additional information. And I prepared the model. I will just show that how to easily create this model very shortly without we will not finish it. So it's like a Lego. You have elements of this. For example, I search for uploaded data sets. Like here, I insert data set. I could look inside it. So I could look at the data, see statistics, the histogram of it, and then I could add a different data manipulations like select columns, split, add records, and things like that. So that is how it works. So all the data manipulation and all data transformations I could do actually by drag and drop and clicking. I could write my SQL script if I want, but actually it's not needed usually. So cleaning missing data, there is additional thing. So that is how I build this report. And here on the bottom, I have the run button, so I could run it, test it, and so on. But let's look, because we don't have enough time to see the full cycle, and it's more for technical things. Let's look at some model I already built, and there is a car demo model. So what I do here, I take an automobile price data for used cars. We could look at this data. We are seeing this data, yes. And then I select the columns that I will predict. I clean the missing data. I train it with a linear regression model, and I actually build it as a web service. So you could see that this looks as a web service. And when it's built as a web service, I could actually use it call it in Power BI. It means that I will take the data from the Power BI, send to this report, and get the score back. And you could see that how this web service look like. You could test it. You could look at the import data and output data. And I will show you how to test it in Excel. So you could, of course, add it to Power BI always. But there is a machine learning add-in for Excel. So you could use it in Excel by adding under an insert. You have this add-ins, and here is you could from the App Store you could get this Azure Machine Learning, and what you could add your own web service. So in Azure Machine Learning Studio, you will get these keys to add and get it. But I will show you how to run it. Here is a schema view, and there is a predict and imagine that you have some data, like here I have the data for the used cars, and I will put, and we don't know price actually. I will use a multi columns, but it could be 5 columns or 10 columns. But imagine that you have the data for used cars. You don't know price. There could be thousands of them. I have 5 right now, and I'm just select it and say that use this data set. And as an output for that, I will provide a one. And when I click predict, it sends all the data to our machine learning model I showed you, Machine Learning Studio, and actually predicts us prices for this. And you see other columns that as an output, use it as an output is and we have this prices here, and you could use this Excel file, for example, to load these predictions in Power BI, or use directly Power BI functionality to load this data using this short script. So before we get this nice functionality to load data using AI in science part. Yeah, I think I'm ready for questions.
Okay, thank you very much, Aldis. Yes, we have quite a few of them. I will not turn my screen on for this one. Maybe you can share. The first question is, you mentioned emails and documents as an uncommon data source in one of your slides. Can you give an example of how these sources could be used in forecasting?
Yeah, remember one of the last session last week, I showed this communication analysis. When you're using email communication between your employees and clients, your employees and suppliers, you could predict the communication, actually, how the good communication is, and you could predict how much time your sales guys should spend with clients that they buy more. So this communication analysis is a whole new field. It's actually scientifically called organizational network analysis, and you could get a lot of information out of it.
Okay, thank you. Next one is, what other tools for doing predictions are available for a non-so-technical user if we do not have Power BI, if any?
Yeah, I recommend to look at KNIME. It's KNIME. It's just some tool to look at and try out. It's you could download the desktop version, free desktop version for it, and try it out. So KNIME, it's one of the tools, and there's a lot of low code tools for AI, ML analysis. If you're using Office 365 in Power Platform, in Power Automate and the Power Apps, you also have today AI Builder, when you could build a machine learning with a very low code approach. It means, for example, for document classification or document information extraction, you could put 5 documents and automatically find how to extract the document number, client name, and things like that. There are plenty of low-code capabilities.
low code. Okay, but we also talked, if some of the attendees haven't joined for the past week, is that the learning curve for Power BI, it's very steep. Yes, you might not be very familiar at day one, but in 1 week you can do miracles already. This is what also Aldis was talking last week about. But the next question, I just try to squeeze everything that we answer all the questions before we end this session. What is the minimum size or rows of data for the machine learning algorithm to have a decent capability of forecasting? So how much data do you need for ML?
Yeah, it depends on task, on the task and type of data, but usually it's a couple of thousand of rows could be enough. So not terabytes of data.
Okay, couple thousand. Last one is a comment and a question, is that Microsoft Azure is great, but basically cloud computing, sometimes enterprises just do not allow to use cloud computing, transfer data to third parties, well, privacy and data privacy and hacks. What arguments would you use to argue that business stakeholders for cloud computing from an IT security and data security point of view, should all organizations trust third parties cloud computing?
Short answer, no, not trust it automatically, but we have plenty of techniques how to make it trustable. Like the simplest one I showed at the beginning of last week, it's anonymization. It's perfect for machine learning. It means do anonymization, and machine learning don't require the raw data, like with all the figures. It's even better if it's anonymized. So if it's anonymized, it's more secure to put it in the cloud for processing. So that is a way how to use machine learning, actually. Do anonymization of your training data.
Okay, thank you. This one's it for this session.